one of the applications of lines are in linear regression. Linear regression is the process of taking data and describing the data by a single line. This will work perfectly for a surfboard company because we have 2 points of data. So recall that we were looking at a company who had 2 variables. We had X being the number of boards being produced in a day, and then Y being the cost. So the daily cost of producing X amount of surfboards was what Y represented. So in the story problem there was it cost them $200 to keep the lights on if they produced no boards at all, and if they produced 20 boards their daily costs were $3,700. So if we're trying to come up with a way of describing how the cost depends on the number of boards, we have everything we need to define a linear model. We have 2 points of information. So from those 2 points, let's define the slope. So m equals the change in y over the change in x. And remember, the order in which we choose this is going to be important. So let's start with the bottom y value. So 3,700 minus 200 divide by, and then if we started with 37, we want to start with the same corresponding value for x, so 20 minus 0. And so if we reduce that, that's 3,500 over 20. By canceling out the zeros here, oops, wrong one. Canceling out the zeros, we get 350 divided by 2, which is 175. Now that's what the mathematical definition of the slope is. It's 175, but what does it really actually mean? And so what's nice to know is what that 175 represents. So that 175 is coming from looking at how the change in the cost, so our change in our cost part right here, divided by the change in our number of boards produced. And so that 175 is actually, so the meaning is that our cost is changing at a rate of 175, so changing cost of dollars per number of boards being produced. So it costs the company $175 per board. So now that we have the slope and we have 2 points, we can come up with the equation of a line by using either one of those points. So we'll use our equation of a line, y minus the y coordinate equals the slope times x minus the x coordinate. We can use either point for x1 and y1. Let's use the top point, it's a little easier, so x1 being 0, y1 being 200, and we'll plug that right into our formula. So y minus 200 equals our slope, which is 175, x minus 0. The reason I want to do that is because now notice that if we were to solve for y, this has I think a logical form. So add 200 to the other side. We have 175 times x minus 0, or just times x, plus 200. So we can see where this cost function is coming from. We have our fixed costs of just keeping the lights on and paying our employees, and then we have the cost per board. So if we knew how many boards are being produced, we multiply that by 175, add our fixed costs, and that would give us our total daily costs. Here are the questions for Tuesday's Quiz 5. Please use the form given on Monday to write in the solutions as cleanly as you can and show all your work. Enjoy! Let's look at another example of linear regression model, and let's work this out now from start to finish. So here's the scenario. A baseball team plays at a large stadium, and they know that the average attendance is 21,000 when tickets are $12. And if the price goes down by $2, the attendance rises to 25,000 tickets. So they are asking us to find a function for attendance as it depends on the ticket price. So how does attendance to the games depend on price? So the first thing we need to do is determine which one's the independent variable and which one's the dependent variable. And the wording of this should give it away. Attendance depends on price. So this is the independent variable. That's what we usually call x. And then the attendance will be y. So y depends on x, attendance depends on ticket price. So let's create a little table. And this is going to just stay there. Alright, cool. Let's create a little table. And let's hey, there we go. And let's put in what we know. So if we're reading above, we are told that average attendance is 21,000 when tickets are $12. So we'll put that into our table. So remember, X is the number of tickets. Sorry, X is the ticket price. So ticket price is $12. The number of tickets is 2,100, so 21,000. And then if the price is lowered by $2, so now the ticket prices are $10, the attendance is 25 people. So this is in dollars. These are in seats, or attendance. So now if we calculate our slope, we'll look at the change in the y values. So 25,000 minus 21,000 divided by the change in the x values. 10 minus 12. So in this case, that would be 4,000 on top and negative 2 down below. Negative 2 divides into 4,000, negative 2,000 times. And now let's see if we can understand what this slope means. It's a now negative value, but does that make sense? So our meaning of our slope is that it's negative 2,000, and the units of this would be, it's a change in the number of seats per dollar difference. So this is saying that this number of seats go down as our price goes up. So as we increase the price by $1, we sell less tickets. Or alternatively, you can think of this being a positive number of 2,000 seats every time we reduce by $1, so negative $1. So that's what that slope means. And now we're going to use that slope and one of the points. Let's take this one right here, since it will stay on the screen as I move this up. And let's talk about the equation of the line. So it's going to be y minus the y coordinate, in this case 25,000, equals the slope, which was our negative 2,000, times x minus the x coordinate, which is 10. And so if we can reduce this a little bit by solving for y, and we have the right hand side being negative 2,000 x plus, right, negative 2,000 times negative 10 will be plus 200,000, and then we're going to add 25,000 to the other side, and that'll be our how attendance will depend on the ticket price. Here you'll find the quiz that's going to replace our Thursdays in class quiz. There are 2 questions with 2 parts. The first question comes from section 3. I believe that's 3.4. We talked about the definition of a function and its domain. And then question 6 is a linear regression type of problem.